everyone, welcome to our short tutorial on Simplex Method. Today we'll explain the steps and go through a sample problem to show how it works.
The Simplex Method, developed by George Danzig, is an organized step-by-step procedure that solves problems involving many variables and constraints. It's used a table format called Simplex Tableau to test possible solution until the best one is found. It's useful in fields like businesses, logistics, and engineering.
Before we begin, here are a few important terms. First, objective function. This is the function we want to maximize or minimize. Second, constraints. These are the limits or conditions we need to work within. Third, slack variables. Added to less than or equal to inequalities to turn them into equations. Lastly, W, a matrix format used in each step of the Simplex method.
Here are the basic steps to solve the Simplex method. First, formulate the objective function in constraints. Second, convert constraints to equations by adding slack variables. Third, set up the initial simplex table using coefficients from the equations. Fourth, identify the pivot column, the most negative value in the bottom row. Fifth, find the pivot row smallest positive ratio of RHS to pivot column values. Sixth, pivot to form a new table. And last, repeat until there are no negative indicators in the bottom row.
Maximize g is equal to 4x sub 1 plus cx sub 2, subject to x sub 1 as x sub 2 greater than equal to 5, x sub 1 plus 4x sub 2 greater than equal to 12, x sub 1 x sub 2 is less than to 0. And we can convert the inequalities into equalities by adding slack variables s sub 1 and s sub 2. So magiging ganito yung ano niya, x sub 1 plus x sub 2 plus s sub 1 is equal to 5, x sub 1 plus 4x sub 2 plus s sub 2 is equal to 4. Also, rearrange the objective function. So, gawin lang natin dito is ililipat natin lahat ng variable terms sa left side. So, ang magiging value niya ngayon is g is equal to 4x sub 1 minus cx sub 2 is equal to 0. So, row 1 natin is corresponding to s sub 1. This row directly came from the first constraint equation. Ito yung x sub 1 plus x sub 2 plus s sub 1 is equal to 5. So, dito naman sa row 2 natin, corresponding to s sub 2. This row came from the second constraint equation. X sub 1 plus 4x sub 2 plus s sub 2 is equal to 12. Sa row 3 naman is corresponding to z. This is row came from the pre-range objective function. Z minus 4x sub 1 minus 6x sub 2 is equal to 0.
Here's the pivoting process. The pivot column is x squared since negative 6 is the most negative in their say row. Calculate ratios. In row 1 we have 5 divided by 1 equals 5, and in row 2 we have 12 divided by 4 equals 3. So row 2 is the pivot row. If we perform row operations to create a new table after all iterations, we get this table formula. We have basic variation x squared, s, and RHS. In row 1 we have x squared, 0.25, 1, 0, 0.25, and 3. And in row 2 we have x, 1, 0, 1, negative 1, and 2. And in z we have 0, 0, 0, 1, and 26. The optimal solution is x equals 2, x equals 3, and maximum z equals 26.
In summarize, the Simplex method helps us find the best solution, a problem with multiple constraints, making it an essential tool in optimization by following the step, setting up the table, pivoting, and iterating. We can efficiently solve linear programming problems. Whether it's maximizing profit or minimizing cost, the Simplex method provides the best outcome while considering limitation.